find the Fourier series of the following periodic signal. So this signal is given. Already we have solved this problem, but instead of this theta, so we have used razor t. If you look at the same, both signals are the same, and here it is a pi, 2 pi, we have taken as a 1 and the 2. So first, as I told you, once again I will repeat all the steps. The first step is you specify that the Dirichlet conditions. So the signal satisfy the Dirichlet conditions, therefore the trigonometric Fourier series exists. The second, you find out the value of t0. So as the signal is periodic, if you look for the one complete period, okay, so the t0 is equal to 2 pi. Okay. So from this you can find out the omega 0 is equal to 2 pi divided by capital T, that is equal to 2 pi, and that is equal to 1. The third step is represent this signal in the form of the mathematical equation. So that is here f of theta. You can use any that independent variable. So earlier we have used t, and here it is used as a theta. So f of theta is equal to its amplitude is a. So a for the time from 0 to that pi, 0 to pi, its amplitude is a, and from the pi to 2 pi, its amplitude is a minus a. So it is a minus a, and as the signal is periodic, f of theta plus 2 pi is equal to the f of theta. So therefore the signal is periodic. The third step is write the mathematical equation of the x of t, where this is x of t is represented. So you can use here it is a f of theta. Then fourth step, you check the DC value. Okay, DC value, that a0 is equal to, check it. So if there is a equal positive half cycle and equal negative half cycle in one period, so the DC value of the signal will be zeros. So here it will be a0 is equal to 0. Then fifth step, you check the symmetry properties. Okay, the symmetry properties. Symmetry properties. So if you check this signal, okay, so here this signal it will be like this, and if you take f of theta, that f of minus theta, so minus theta, so this signal again it will start. So the signal is not even, so the signal will be odd. If the signal is odd, then an is equal to 0 and the bn is not equal to 0, and you can find out the value of the bn. And you check the half periodic wave. The f of theta is a half periodic wave, so only odd harmonic exists. So for n is equal to odd, the signal exists. So accordingly you can calculate the values of the bn for the odd harmonic. And the last step is write the equation for the trigonometric Fourier series and you represent it. So these are the steps which need to be followed to find out the trigonometric Fourier series for any problem. Now find out the a0. You know the formula for the a0, 1 upon that capital T. So capital T is equal to 2 pi you can put, and integration for the one complete period, that is 0 to 2 pi f of theta into d theta, that already we have calculated. So accordingly it will come as a 0, and already we have solved this problem. Just we have considered in the previous problem that t instead of the theta. So everything is same. So a0 is equal to 0, it will come. Okay. So next you find out the an, and accordingly the an is equal to 0 because signal is odd. If the signal is odd, the even coefficient, that an is equal to 0. So directly also you can write, and even you compute, so value of the an will also be equal to 0. Next you find out the bn. Okay, so this already we have calculated, only we have considered t instead of theta, and bn is coming out to be that a upon the n pi, 1 plus 1 plus 1. So when the n is equal to odd, when n is equal to even, it is equal to 0, and you write the trigonometric Fourier series formula, and you can represent this signal as a x of t. So this is nothing but your x of t, which is represented in terms of the sine and the cos. So this is consists of only your the sine and the cos component. So accordingly, so if you write this the equation in the MATLAB, so you can exactly reconstruct the signal which is shown graphically x of t as it is. So this is called as the trigonometric Fourier series. But as I told you, the trigonometric Fourier series is infinite Fourier series. Okay, infinite Fourier series. When you want to represent or reconstruct the signal, we have to consider certain number of terms. So if you consider the 4 terms, so accordingly the reconstruction will be different. If you consider 8 terms, or if you consider the infinite terms, the signal will be represented exactly as it is. So if you look at the number of terms, if it is a finite, okay, So when we consider the 4 terms, you will find the 4 peaks. The signal is not exactly as it is. So when you consider the 6 terms, so there will be 6 peaks will be there. As you go on like this, so 8 terms, 8 peaks will be there. Then 12 terms, 12 peaks will be there. As you go on the infinite number of terms, the signal will be exactly represented as it is. So if you see, when the red is 12 terms and the blue is 4 terms, you will find out the some error. So that is the difference between the actual signal which is reconstructed, actual and the reconstructed signal that will be there. So if you take infinite number of terms, the signal will be reconstructed as it is. So this is the trigonometric Fourier series. Okay. This signal also we have solved. For this, the signal x of t is shown here. Only x of t, it is called as the f of t here. So this problem is already solved. So accordingly, a0 is equal to 1 by 2. So an is equal to the 0 for n all values of n, and bn is equal to this we have got, and this is present only for the odd values of n, and for n is equal to even it is 0. So this signal we have seen that the signal, this f of t can be represented by using sinusoidal component. So like this. So exactly by using this equation you can reconstruct this signal. So this is trigonometric Fourier series. Okay. Now sometimes if the signal is continuous, for example if there are some like the triangular type of the signals are there. Okay. So when you are writing such kind of the signal as x of t, so that time, so you have to write the equation of the line. So when you are writing equation of the line, so that time you have to use the integration by the parts. So this is the formula for the integration by the parts, and just I have solved already this problem and quickly we will go through it. Okay. So this is a problem x of t. So if you look at this problem, already I told you by using symmetry properties you can predict the trigonometric Fourier series coefficient. So this signal is a discontinuous. If it is discontinuous, then your x of t or the trigonometric Fourier series coefficients are proportional to 1 upon n square. And for the half wave symmetry, so this signal exhibits the behavior of the half wave symmetry, only odd harmonics are exist. Okay, odd harmonics are exist, and there is equal positive half cycle and the negative half cycle. So your the a0 is equal to 0. The signal is even. If the signal is even, the bn coefficient equal to 0 and an coefficient will not be equal to 0. Only you need to find out only the an coefficient. So around 70% of the answer you can guess from the symmetry properties of the signal, and you use all the steps that t0 you find out this equal to 2, from this find out the omega 0, and you find out this an values, so which is coming out to be 8a by n square, so proportional to n square. So you will get this kind of the values, a0 and bn will be 0, and from that you can write the trigonometric Fourier series equation, and this the trigonometric Fourier series equation, it is coming out to be like this. So this is called the trigonometric Fourier series. Okay, this is the same kind of the problem. So instead of here we have taken x of t, f of t. So this is a solved problem. So you can go through it, and accordingly you can represent the trigonometric Fourier series for this. So this is a trigonometric Fourier series. So f of t will be like this. So when you write this equation in the MATLAB or any other the software, so exactly you can reconstruct the signal as it is. This is also another signal which is shown here. So the mathematical equation is written, the problem is solved. You can also go through it. So you find out the a0. Okay, it is coming out to be pi by 2. Then you find out the an. Okay, so this find out the bn, and from that you can write the trigonometric Fourier series equation. So like these are some of the solved problem, you can go through it.